So here we have a problem. So we are given a whole bunch of values for f and f prime, and we want to find the definite integral from 1 to 4 of x times the second derivative of f times, so that times x with respect to x. So if we look at this, we see that what's inside the integral, or the integrand, is a product of two functions. So what this is telling us is we should use integration by parts. So if we take the antiderivative of this, well, the antiderivative of the inner function, we can just use integration by parts, which the formula I can write down as, if you have the integral of u dv, it is equal to uv minus the integral of v du. So we can go about and rewrite our antiderivative of the inside of this definite integral. So we can rewrite that as, let u equal x, let du equal dx, that's just from differentiating. dv is going to equal f double prime of x dx, and v is going to be the antiderivative of that, which is just f of x. So what we are going to get from this is a simplified integral. So what we're going to get is x times f prime of x minus f prime of x dx, the integral of that. So if we continue with this, well, the integral of f prime of x is just f of x. So if we want to do this for 4 and 1, then this is just going to be equal to x times f prime of x minus f of x evaluated at the upper and lower bounds, which are 4 and 1. And we know this because of the fundamental theorem of calculus. So if we plug in our values, we have 4 times f prime of 4 is 6 minus f of 4, which is 10, minus the same thing for 1, which is 1, times f prime of 1, which is 7, minus f of 1, which is 7. So what we get here is 24 minus 10 minus 7 is 0. So our final answer is 14.